T-score in SPSS. T-score is a standard score that have a normal distribution, and the distribution have a mean of 50 and a standard deviation of 10. T-score is different from Z-score. Both of them are normally distributed. Z-score have a normal distribution with a mean of 0 and a standard deviation of 1. T-score permit comparison between variables when the measuring scale or unit in each variable is different. To do a T-score, I had inserted 100 cases for 3 groups of data labeled as data 1, 2, and 3, and to compare the scores within this data, we're going to convert this data into T-score. But before converting the data into T-score, first we have to convert the data into Z-score. So these data, I've already checked them and they are normally distributed, and they have, each data has its own mean and standard deviation. To double check that, click on Analyze, then click on Descriptive, click on Frequencies, select these 3 variables, and then take here the mean and the standard deviation. Chart here also, we're going to look at the distribution of the data, and if we click on OK, a table is generated here that shows the mean and the standard deviation for all the 3 data or variables. And as we can see here from the histogram, for each of these variables, these data are normally distributed. So to convert this data into Z-score, first click on Analyze, click on Descriptive, Statistics, and then Descriptive. In the Descriptive window, select the 3 variables, transfer them to the box for under Variables, tick the box for Save Standardized Values as Variables. And then in the options, we're going to stick with the mean and the standard deviation for each of these variables. And if we click on OK, again, variables for Z-score for each data is generated for data 1, 2, and 3. And as we can see here, these data has a negative, or these scores has a negative and positive scores. Negative scores means that the score is lower than the mean, which is 0 in the Z distribution, and the positive score indicates that the score is higher than the mean. So once we have calculated the Z-score for each variable, then we can convert the data into T-score. And the way to do that is to click on Transform, Compute Variables, and in the Compute Variables, we're going to generate a variable, we call it T-score 1. And for that T-score 1, to convert that into T-score from Z-score, we need to add the mean, which is 50, plus the Z-score for the data number 1, and then transfer that into numeric expression, multiply that by 10 for the standard deviation of the T-score. And if you click on OK, a new variable is generated. These data have a mean of 50 and a standard deviation of 10. We're going to repeat the same thing for the rest of the data. So we're going to call that T-score for data 2, and then we're going to change the z-score for data 2, insert that here, and then click on OK, and again t-score for the second data is generated here. Repeat the same for the last variable, and we're going to remove the this, select the z-score for data number 3, click on OK. Again, a third t-score is generated for the third data. So if we look and examine the distribution of these t-score data and their mean and their standard deviation, click here into a descriptive, then frequency, and then we're going to select all the z-score and then the t-score all together, and I'm going to look for the mean and the standard deviation for each variable. And chart, we stick with the histogram, and if we click on continue and then OK, a table is generated showing that data 1, data 2 and 3, their mean and standard deviation. For z-score, the mean is 0 and the standard deviation is 1, and for the t-score, the mean is 50 and the standard deviation is 10. And this histogram shows the distribution of the t-score and z-score. And if we scroll down here, you see that the t-score for data 1 has a mean of 50 and a standard deviation of 10. And these all data are normally distributed. So this is the way to convert raw data into t-scores by first doing an intermediate step, transferring or converting or transforming the data into z-score, and then from z-score calculate the t-score in SPSS.